Researchers develop design scheme for fiber reinforced composites. Their novel computer-aided approach simultaneously drive the best microstructure and locally optimize microscale fiber densities. Date February 24, 2022. Source Gwangju Institute of Science and Technology. Summary: researchers have developed a scheme for AI-assisted design for fiber reinforced composites structure with spatially varying optimal fiber size, making FRC more lightweight without compromising their mechanical strength and stiffness. Fiber reinforced composite, which are engineering materials comprising stiff fiber embedded in a soft matrix, typically have a constant fiber radius that limit their performance. Now, researchers from the Gwangju Institute of Science and Technology in Korea have developed a scheme for AI-assisted design for FRC structure with spatially varying optimal fiber size, making FRC more lightweight without compromising their mechanical strength and stiffness, which will reduce the energy consumption of car, aircraft, and other vehicles. Fiber reinforced composites are a class of sophisticated engineering materials composed of stiff fiber embedded in a soft matrix. When properly designed, FRC provide outstanding structural strength and stiffness for their weight, and making them an attractive option for aircraft, spacecraft, and other vehicles, where having a lightweight structure is essential. Despite their usefulness, however, FRC are limited by the fact that they are designed using fiber with a constant radius and a spatially fixed fiber density, which compromises the trade-off between the weight and mechanical strength. Simply put, currently available FRC are, in fact, heavier than necessary to meet the application standard. To tackle this issue, an international research team led by Professor Jaewook Lee of the Gwangju Institute of Science and Technology in Korea recently developed a new approach for the inverse design of FRC with spatially varying fiber size and orientation, also known as functionally graded composites. The proposed method is based on the multiscale topology optimization, which allow one to automatically find the best functionally graded composite structure given a set of design parameters and constraints. Topology optimization is an AI-based design technique that relies on computer simulation to generate an optimal structural shape instead of on the designer's institution and experience. Explained Professor Lee. On the other hand, a multiscale approach is a numerical method that combines the result of analysis conducted at different scale to drive structural characteristics. Unlike similar existing approaches that are limited to two-dimensional functionally graded composites, the proposed methodology can simultaneously determine the optimal three-dimensional composite structure alongside its microscale fiber densities and other fiber orientations. The team demonstrated the potential of their method through several computer-assisted experiments where various functionally graded composite design with constant and varying fiber size were compared. The experiment include design for a bell chunk, a displacement inverter mechanism, and a simple support beam. As expected, the results show improved performance in the designs with locally tailored fiber size. This paper was made available online on October 9, 2021 and published in volume 279 of Composite Structures on January 1, 2022. Many applications for vehicle, aircraft and robotics benefit from lightweight structure, and the proposed approach can now assist engineers to this end. However, the benefit can extend well beyond the target applications themselves. As Professor Lee explained, our methodology could help develop more energy efficient vehicles and machinery by weight reduction, which would reduce their energy consumptions and in turn contribute toward achieving carbon neutrality. Thank you for watching and supporting me. Please subscribe to my channel. Thanks again.